Drylands form collectively the largest biome on Earth and host 1 in 3 humans inhabiting our planet. In these places, life is highly conditioned by aridity, the balance between rainfall and evaporation. The less rain and more evaporation, the greater the aridity of a place. Aridity is increasing in drylands worldwide due to climate change. This ongoing aridification of our planet will exacerbate the water deficit already experienced by drylands, albeit the consequences of this climatic change for their biota and ecosystem services they deliver are poorly understood. A study led by the Dryland Ecology and Global Change Laboratory of the University of Alicante and published in Science provide new insights on the impacts of increases in aridity on dryland ecosystems.
One may think that dryland ecosystems will slowly and gradually respond to increases in aridity conditions like those expected under climate change to become a more desert-like ecosystem. However, there is the prevailing or an alternative hypothesis suggests that ecosystem changes to environmental stressors like aridity occur abruptly rather than gradually and may lead to drastic ecosystem transformations.
The purpose of this study was to evaluate whether acidification exerts gradual or abrupt responses in drylands worldwide. To do so, we evaluated more than 20 ecosystem attributes and functions and look at how they respond through the large aridity gradients that can be found naturally in our planet. With this exercise, we look at the changes that occur through space to have a better idea of what can be found in the increases in aridity that are expected for climate change.
So what we found is like all the ecosystem attributes we measured, they react in a nonlinear way or respond nonlinearly to aridity, and these changes might be organized in 3 transitions, abrupt transitions that occur in drylands and that might affect ecosystem functioning drastically in the future.
The first threshold occurs at aridity levels of 0.54, similar to the aridity values that can be found in many areas of the Mediterranean basin. Here, a nonlinear drop in vegetation productivity occurs once this threshold is crossed. On a milder aridity levels, water is not such a strong limiting factor and plants develop a high diversity of growth forms, from small shrubs to trees. When we cross this threshold, plants have to adapt to water deficit by, for example, exhibiting tough and small leaves that allow them to endure prolonged drought conditions. As aridity increases, forests are no longer able to thrive and vegetation turns into shrublands. When aridity levels of 0.7, similar to the ones found for Almeria or Morocco, are crossed, soils experience abrupt losses in fertility and microbial activity. For instance, strong declines in the relative abundance of mycorrhizal fungi, which effectively extend the root area of plants and are extremely important for acquisition of essential nutrients like phosphorus, occur. Finally, when aridity crosses the value of 0.8, the cover and diversity of perennial vascular plants decreases suddenly. Beyond this threshold, biotic activity is drastically reduced and life becomes conditioned by windows of opportunity arising by episodic rainfall events. Ecosystems turn now into deserts. Climatic forecasts suggest that around 20% of emerged lands may cross one or several of the aridity thresholds identified in this study by 2100.
If everything develops in time, as we have seen across space, we will face sudden changes in our environment that will force us to change our livelihood. Our findings are of paramount importance for developing strategies of mitigation and adaptation to these changes. After all, life will not disappear with climate change, but it will transform, and we need to be aware of this transformation. you.